In this video, we're going to learn the difference between annual compounding and intraperiod compounding.
This is where I always want to start when I'm trying to teach people about compounding and discounting and any other of these time value of money finance calculations. This is the most basic starting point. This formula is basically saying if I want to know the future value of some investment, that's the present value, the dollar amount that I put into the investment today, it's a simple matter of multiplying that present value times, open parentheses, 1 plus I raised to the n, where I represents the interest rate and N represents the number of years you're going to let this investment sit and earn interest. One important thing to note if you're going to use this formula or any function in Microsoft Excel to calculate this is you've got to pay really close attention to how your interest rate is formatted, because the formula wants a decimal. If you're going to calculate 12% interest, the formula wants 0.12. So always pay very close attention to the way things are formatted, because you've got to convert it before you plug it into the equation so that you get that decimal percentage. Again, if you're calculating 12% interest, this formula expects you to use 0.12 for I, your interest rate. And N, again, is the number of years that you're going to let this investment sit. I like to call this a specific formula, meaning it is designed for one very specific situation, and that situation is annual compounding. This is going to calculate interest once per year. So I've just cut the tape and I've brought a second formula on the screen. What I want you to notice is that the two formulas look a whole lot alike. The only difference is in the second formula, I've taken the interest rate, I, and divided by K. And I've taken the number of time periods I'm going to compound, the exponent in the first equation, and I've multiplied it by K. So what is K? K is the number of times per year that you plan on calculating interest. So if K was equal to 1, the two formulas would be the exact same formula. Basically what we're doing with this is we're saying, hey, why don't we try calculating interest monthly? If you're going to do that, then you're going to compound 12 times a year instead of just 1. So you've got to multiply N times 12, that's what N times K is, in order to adjust for that. But you have to remember that you're not going to use the full interest rate in that scenario. You're going to have to divide the interest rate by the number of times in the year that you're going to compound. So you've got to divide the interest rate by K. So if you're going to compound monthly, you have to take your 5% interest rate, for example, and divide it by K, 12 months in a year. And you can set K to anything that you want to set it to. You can compound quarterly, you can compound monthly, you can compound daily, whatever you want to use for the formula. And so this bottom formula is a very general formula, meaning you can manipulate it to work in almost any situation. So let me pull into Microsoft Excel, and I'm going to actually enter these formulas in Microsoft Excel and show you how to input them. And then I'm going to show you how to use Microsoft Excel's functions in order to do the exact same thing. Okay, so now I've switched over to Microsoft Excel and I've entered the parameters that I'm going to use to do these calculations. If you'd like to hit pause and enter these same parameters, feel free to do so. I've started off in cell C3. So let's start with a present value and let's pick a number. Let's say that you had $1,000 that you wanted to let sit in some investment and earn interest. So we'll type in a $sign and then 1,000 and hit enter, and what we're going to see is that Excel is going to automatically format that into an accounting function. Then I'm going to come in here and I'm going to type 12%, and Excel is going to format that for me automatically, and so Excel is looking at that and it sees 0.12. Now the years, what do you say we compound for 10 years just to have a number to work with? And then let's do this for 12 periods in a year, so we're going to compound monthly. So what I'd like to do is I would like to enter my formula for calculating the future value when I just compound one time a year, the annual compounding. So we type an equal sign in Microsoft Excel in order to demonstrate to Excel that we're going to be giving it a formula or an equation to work with. And we're going to click on the present value of the investment, the $1,000. And then we're going to multiply, and we multiply in Excel by using an asterisk. And then I'm going to type in open parentheses, and I'm going to type 1 plus, and I'm going to click on my interest rate of 12%. I'll close that parentheses, and then I will hit Shift and 6 to get a caret. So a caret is used when there's an exponent. That signals Excel that we're going to enter an exponent when we want to raise something to a given power. And we're going to raise it to the number of years that we're going to compound, and we're going to press Enter. And now we'll format that. Just click on the cell and go up to the top of the home ribbon here, and we'll click on the dollar formatting and press Enter. So if we compound this thing for 10 years at 12% interest, it'll turn into $3,100 and some change. Let's take a look at what happens if we use intra-period compounding, if we do the same thing. Now the trick here is we have to compound it for 120 time periods, but we can't use the full 12% interest for those 120 time periods. That would be the same as compounding it for 120 years. We're just doing 10 years, we're just doing it more often per year. So we'll type an equal sign, and again we'll click on the present value, the amount we're putting into the investment, an asterisk, and then a parentheses, and 1 plus our interest rate of 12%. But there's a problem with the interest rate. We have to adjust that interest rate for the fact that we're going to be compounding 12 times a year. So I'm going to divide by the number of periods in the year. Then I will close that parenthesis, and just for good measure, I'm going to take that fraction and I'm going to surround it with parentheses. Because to be perfectly honest with you, I don't know how good a job Excel does keeping up with order of operations. And so I always like to load my formulas up with extra parentheses to make sure that I force Excel to use the correct order of operations, or at the very least, if I'm doing it wrong, I'm going to force Excel to use the order of operations that I want it to use. I always do that. It's overkill. All right, moving to the end of the formula, going to hit Shift and 6 to get the caret, open the parentheses again, and now I have to do the number of years, but I got to multiply that by the number of periods, 12, and then I close the parenthesis. And then I press Enter. Well, before I press Enter, what I want you to notice real quick is everything is color-coded. All right, we know exactly where we're pointing to because it's all color-coded. There's a cell outlined in green, one outlined in purple, one outlined in red, and that's all really handy. And I see a mistake when I'm looking at my color coding. I don't know why, but for some reason, this is pointing to cell D38, and I'll tell you why. When I went to type the asterisk, I didn't hit the Shift key, and so it gave me an 8 instead of an asterisk. So I'll just go in and fix that. Everyone makes mistakes. You just got to fix them when you make them. Press Enter, and we get 3,300. Let's format that. Click on the cell, go to the home ribbon, over to the number formatting, and hit the dollar sign, and we see $3,300 and some change. Notice how you got a different number. The more frequently you compound, the more money you're going to have in the investment. The future value of this investment will be higher if we compound more often. And that's an important thing to remember. Now that was really neat. We've seen how to take a textbook formula, and I pulled that textbook out of I pulled that formula out of a textbook. The textbook I used was Fundamentals of Agribusiness Finance by Ralph Battles and Robert Thompson Jr. It's probably a 20-year-old textbook. This formula hasn't changed in eons. So the next thing that I want to do is I want to show you how to do the exact same thing but to use Microsoft Excel. So what we'll do is we'll come right here off to the side and we'll enter again future value and future value enter period. Actually, I know a better way to do that, y'all. Let's do it the quick, easy way. I'll type an equal sign and click on future value annual and press enter, and then I can just drag that cell down. I don't have to waste all my time typing and run the risk of a typo because I tend to make typos and misspell words. So the function in Microsoft Excel to calculate the future value is just the future value function. So you basically type an equal sign and then FV, and then you get this menu start to pop up, right? And it even tells you right here on the screen that this returns the future value of an investment based on periodic constant payments and a constant interest rate. So we'll type in open parentheses, and Excel is going to start giving us prompts. The first thing it's going to ask us for is the interest rate. Well, our interest rate is 12%, right? And then it's going to ask for the number of periods. Well, the number of periods is 10 because we're going to compound for 10 years. Then it asks for a payment. We only use the payment if we're doing what we call an annuity, which is a stream of payments. So if we were to put $100 per month in our investment, we would use the payment argument, but we're not. We're just taking a lump sum at the beginning. So we're going to type a 0 and then a comma, and then we get to the PV argument. That stands for present value, and you'll notice that it has brackets around it. That signals that it is an optional function. The default is 0. So we're going to click on 1,000. And oh, by the way, Microsoft Excel is going to calculate this wrong. So we put a negative sign in front of it. This is based on cash flows. Think of it like this. If I put $1,000 in the investment, that's $1,000 coming out of my normal cash flow and going out of my checking account, so I have to input it in as a negative cash flow. Finally, there's the type, which we're not going to need for this purposes, and it's also an optional argument, so I'm just going to close the parentheses and press enter. Next is the interperiod version. It is the exact same function in Microsoft Excel. We just have to modify it to account for the fact that we're going to compound 12 times a year. And we have to modify the number of times we compound, and we have to modify the interest rate. So we'll type FV for future value and then open parentheses. And then we click on the rate, right, which is 12%. But we can't just enter 12%. We have to divide it by 12, the number of times we're going to compound. So I type a slash to divide, and I click on the periods per year. Now I type a comma, and it wants the number of periods. We're going to do this 10 years, but we're going to do it 12 times over 10 years. The number Excel is looking for here is 120, so we have to do the years multiplied by the periods in a year. Then a comma. Once again, the payment's blank, so we'll do a 0 and a comma. And then we click on the present value, and we don't forget we want a negative sign there. And finally, we'll just close the parentheses and finish the formula and hit enter, and we get our result. Now here's what I really think is neat about this. The second formula that I use, the intraperiod formula, is the better formula. It's longer, it's more complicated, but it also is more versatile. Let me show you what I mean. Let's say I only wanted to compound once per year. I can just go into my spreadsheet and change this 12 to a 1 and press enter, and now the second formula will do the same thing as the first formula will do. Meaning you never really ever want to use the first formula. You always want to use the second. That way, if you want to sit down and make an adjustment to your spreadsheet later, you can adjust it in an infinite number of ways. Let's say, for example, I wanted to compound interest once per quarter. That would be 4 periods per year. Type a 4, hit enter. Spreadsheet updates automatically. Neat and clean.